All right, my friend, today we are at C6. We are halfway to this madness. And this time we have to make few exercises. This is a short chapter. So we have to make a program that is able to print the program name. For example, it has to be able to print a.out given the name of the program, which is a.out, the classic standard compiled file. Then we need a program that is able to print all the command line arguments. For example, with this output, it has to be able to print test 1, 2, and 3. These are the first, second, and third inputs in my command line. Then the same program essentially, but this time it has to print all the inputs in reverse order. It's going to be trivial. And then, of course, the last exercise, which is the most complex one, in which we have to sort all the arguments in lexicographical order, basically like in the dictionary. Okay. All right, I think we are going to tackle all these exercises all together, given that they are highly related and given that this is a short chapter, okay? All right, here I have a boilerplate program in C. I have included my standard input-output header file, which contains the input-output functions like printf, and then my main function that you know is the typedef function, the one that is going to give rise to all the program itself. This is the first function that is gonna be called. So the main name is special for C programs. Up to now, you're used to have no inputs for the main function. Indeed, this is the first function. Who is gonna give inputs? Who is gonna give arguments to this function? Given that this is the first one. The main function can take some inputs, and these ones are argument counter and char star argument vector array. Boom. So these are the inputs that the main function can take. From who? Well, it can take it from the environment, from the shell. Indeed, this is an array of pointers to the arguments given at the command line. And this is just the number of arguments given at the command line. Maybe by now it's cryptic, I will explain very well how it works. So you see, these inputs are just a way for the shell, for the environment, to communicate with a C program. For example, I have bash in my terminal. When I'm gonna launch this process, I'm gonna give all the inputs given at the command line level, right? All the arguments and even environment variables. I will show you immediately what I'm talking about. All right, so for you, this is easy. This is an integer, nothing to understand here. This is a more complex data structure. It's an array of pointers. You can indeed write also this argument vector like that, because you know when arrays are given as an argument, they are gonna decay into pointers. So if you write like that, or if you write like that, it's gonna be exactly the same beast. Now we're gonna have a visual grasp of this data structure. So it's gonna be super easy. All right, here we have our argument vector. As I told you, the argument vector is a pointer to an array of pointers. So we have argument vector that is pointing to this array. I have argument vector in position 0, in position 1, in position 2, as many pointers, as many arguments. In this case, in my stupid example, I have only 2 arguments. Namely, I have hello and world. The first argument in my array is always the path of the program itself. So in this case, I have an argument vector in position 0, the name of the program, a.out. So you basically have the solution for the first exercise here, visually. It seems complicated to understand how to exploit this data structure, but it is not. For example, if I want to dereference the first string, how can I do that? Look at that, I have argument vector, square bracket 0, square bracket 0. What is that? Well, with the first square bracket, I select the string, aka the pointer. So in this case, I select the first pointer, the one in position 0, argument vector 0. With the other square bracket, I select the char. I select the char, in this case, is gonna be the point, because it's the char in position 0 of the string. Okay, is it confusing? Let's try another example. In this case, I have the char in position 1. In this case, is the slash, you see? Cool. Same idea here, for example, argv 04. I select the pointer in position 0. And then I select the char, which is in position 4. Easy, right? If you have the square bracket notation, it's going to be almost trivial. Let's see another example. For example, we have argv in position 2. So I select the pointer in position 2 in my array of pointers. And then I select the char in position 3 in the string pointed by that pointer. My friend, I think it's super easy, right? If you have the square bracket notation, which we know is syntactic sugar, but we don't give up, you know what? It's trivial to dereference and exploit all these pointers. This is the image that you need to imprint in your mind to do all the exercises. Okay, let's change a little bit the program of before. And now we're gonna do exactly what you just saw. We're gonna do printf. We're gonna print a char. Which one? We're gonna take argument vector. We're gonna choose the first pointer, namely the one in position 0, and then which char? We're gonna choose the char in position 0, okay? Basically, we're doing this, my friend. Selecting the first pointer, the first char. We're gonna compile the code, okay? Compile, then we're gonna launch out hello world. All right, I'm gonna get a point. That's exactly this slide. We selected the first pointer in my array of pointers and the first char. Of course, they are the ones in position 0. Let's change a little bit the code. This time you're gonna select the pointer in position 0 and the char in position 1, okay? Let's see this time how it works. As you can see, I have the slash here. That's this idea, my friend. You see, I select the char in position 1 of the pointer in position 0. Let's make the last one just to make extremely clear what I'm doing. I'm gonna do 2 and 3. So I'm gonna select the pointer in position 2 and the char in position 3 of that specific string, of that specific pointer. Okay, we're gonna close, compile, and then run the same. I get an L, and that's exactly the letter I want because I select the pointer in position 2 and the letter in position 3, which is an L. Perfect. Now I want to show you something a little bit different. I want to make an explorer program. Where do these arguments are going to be stocked in our memory? So very briefly, I have my main function. I have a char explorer, that is this character, and then I have a pointer to the explorer. Then I say while 1. This is basically while infinite, because 1 is always true. Then I have this condition, which by now we're going to forget. Better, I'm going to comment so you can understand what it's doing. And basically we are while infinite, I'm going to print what is pointed by my explorer plus plus. So I'm gonna go up the stack because, you know, this is a variable that is gonna be put in the stack, and making this plus plus, I'm gonna rise up the stack because, you know, the stack is going down. Basically, every time you launch a program, it becomes a process. A process is a program that is running, and you have this memory layout. This is, of course, very superficial, just to give you an idea. You can search by yourself process memory layout, but as you surely know by now, you have a stack, you have an heap, and then you have other areas that contain like the data, for example, the strings, the literal strings, and text, which contains the instructions and so forth. But now we're gonna do our research in the search area, which is just up the stack, okay? As you see, the stack is going down and the heap is rising up. So when I increase the addresses, I'm gonna go up. You can recall that by heap is rising up, is doing up is rising, okay? That's a stupid trick. All right, let's see what do we get. So we're gonna run our program explorer. Boom, we get all this stuff. As you can see, we don't have a clear format, but nonetheless, I have executable path with the path to this program, you see? Then I have other stuff. It seems to make sense, but the problem is that we don't go on the next line when we stumble upon a 0, okay? That's the problem. That's why I have this piece of code. So I'm gonna uncomment and we're gonna launch again. That's better, right? Look at that. Now I can see very well what is happening. These are the environment variables that I was talking to you about. Basically, we have the working directory, we have the name of the process, we have my username, and we have the shell. In my specific case, I use fish, which is a very cool shell. But probably you're using bash, but that's the same idea. And other information. These are the environment variables if you want to check by yourself. And all other stuff, as you can see, there is a lot of white spaces, question marks, and so forth. Question marks because probably we have negative chars here, so unrecognized chars. Okay, so this is up the stack. This is all stuff that is stocked just up the stack. Now we're gonna do again with some input at the command line. Well, damn you. Boom, we're gonna launch again. And as you can see here, I have all my arguments. I have the name of the program, and then I have hello world, damn you, which are the command line arguments. You see? So these strings are stocked just over the stack. So all the strings that we're giving as an input to my program are in the search area, okay? As well as all the environment variables. So we can also use the environment variables in my program. So for example, indeed, in my program, so I can also have another array of pointers that is called the environment one. And I can write in this fashion. In this case, I can do printf. This time I want to print a string, and I'm gonna just print in my environment, I don't know, the first one, the first environment variable. Yeah, I just wrote it bad. I need env. Okay, we're gonna compile and run again. As you can see, I have my first environment variable. Print working directory. For example, in my fish, I can see these environment variables like with this command, which is env. As you can see, this is the first environment variable, essentially like this one. It's gonna be very easy to me to write a C program that is able to print all the environment variables. I don't know, in bash, I think it's the command env. Yeah, it's exactly the same. These are informations about your system. So you see, like the shell can communicate to the programs thanks to these command line arguments. Now I'm gonna exit bash. By the way, I highly suggest to you fish, less cryptic than bash. Another thing that I wanted to tell you, it's that you can write whatever you want here. For example, argument counter, totally. You can stream vector, and here you can say, I don't know, blah, blah, blah. That's totally fine. You can do that. Let's see if it's gonna work. And as you can see, it's gonna work the same. Why? Well, because these are simple arguments, like every function. Every function is gonna give the names that it wants. The thing is that these are positional. So in the first position, I have always to put the counter of the arguments. In the second one, I have to put the argument vector, and in the last one, the environment vector, right? The important thing here is the position, it's not the name, like in every other function. All right, you have a good framework to do the exercises, I think. All right, so let's start from the first exercise. You have to create a program that is able to print the name of the program itself, namely a.out. My friend, this is the program to write the first command line argument. Of course, we can use the Unix standard to use the write function. Here you have the putchar, you know very well by now. And then here we are with the main function that is taking the argument counter and the argument vector inputs. Then very stupidly, I just declare iterator I. I need to do this trick to avoid the flags of the GCC because I have to use all the arguments. So I'm gonna just cast my argument counter to a void. I is equal to 0. And then very stupidly I say while argv0. What is that? You saw it before. argv0 is the pointer in position 0 in my array of pointers. So I select that one. By convention, in this position, in this pointer, you have the path of the program itself, namely point a.out. So I select this pointer and I select the first char. I need to iterate until what? Until I stumble upon the \0 of that string. Like you would do for a normal string, you iterate until you find the sentinel value \0. So here we're gonna do exactly the same. I'm gonna select the pointer in position 0, which is the one of the name of the program, and then I have my iterator, which is I. I will print the char pointed by I, which initially is 0, namely the point, and then very stupidly I'm gonna increase I, okay? So this expression is like saying while this char is different from 0, as you perfectly know, I'm sure by now, writing like that is totally the same, it's totally redundant, because I will use the value of the sentinel value \0 as a boolean value, namely 0 for false. So I can really skip that, but maybe it's more readable with this one. I'm gonna print char by char. So I can leave it like that. I'm gonna close and run. As you can see, I have in my standard output the name of the program, the path of the program. All right, I think this exercise is kind of simple once you get what is this command line stuff. All right, now we're gonna print all the parameters. We have to skip this time the first a.out. We don't care about that. Here comes the program. This time it's kind of longish because I have two ways of solving the same problem. I have a pro way and a less pro way. Let's start from the less pro, which is gonna be easier. Okay, let's uncomment that, and I'm gonna comment the pro solution. Okay, cool. All right, let's see what we have. We have, of course, the usual put char that you know, and then we have the main function, of course. The same idea as before. I'm gonna trick the flags. This time I have two iterators. I have j and k. j this time is equal to 1, and then I have a nested while loop. You know very well by now because it is like the print combination of the C0. I'll leave you a link so you can maybe refresh your memory. And I say while argv in position j is equal to 1. So I start from the pointer in position 1 because I want to skip the path of the program itself. I don't care. I just want the arguments. And then I have k, which is equal to 0. Every time k is going to refresh to 0. Then I have while this condition, argv jk, what is that? Well, this is the char pointed by j, which initially is 1, and k, which initially is 0. So this is the char in position 0 of the first pointer. So namely, until this is not the \0, again, here I can write like that. I can write is different from \0, totally the same. Maybe this is more readable. Okay, let's stick with it. What do? I just print that char and I increase k. So basically I'm looping into the string, searching for the celestial value \0 until I'm searching for that. I'm gonna print char by char, easy. So this is a loop that is gonna print the string itself. This loop is gonna break when it's gonna exhaust all the string. So we're gonna continue with j++. Namely, I'm gonna go to the next pointer in my array of pointers. And of course, I'm gonna print a new line to make it more readable. This k every time is refreshing at every iteration. So we can always start from the char 0 of the respective pointer. So here again, I just used argvj because I'm gonna use the last 0 value. In this case, we don't have a \0, but we have a value which is null. For pointers, we use null, but this is a 0. \0 null is always 0. It's always the same beast. So we're gonna run this code. As you can see, I have hello, then you, very easily, right? Every time I'm gonna print all of them, and yeah, I don't think there is nothing difficult about this code. If you are at this level of the PC, it is easy, right? You have a nested while loop. Until my array of pointers is not finished, start from the char 0 of all the strings. And what do? And print all the char inside the string until you stumble upon the sentinel value 0. Then just go in the other string, put a new line char, and do it again. Okay? That's super easy for you at this level. Okay, let's very briefly check the pro solution. In this case, I have a special function which is ft put string. So I have doped a little bit the put char function. I have while at str put str ++. It's here. Namely, I say while at str, namely until I'm not again in the last \0 of the string, namely the sentinel value. I always use the char pointed as a boolean value itself. You write that in the standard output, you write the string, you know, the write function is going to take a pointer. It's going to use str and then it's going to increase. So the increase is going to happen inside the write function. And then at the end, you're going to just print a new line. Super easy. These 3 lines are going to print a string. When the string is over, we're going to print a new line. That's exactly like the put string function. You can check, you write man3 put string. Then very easy, in 2 lines, I can solve this problem because what do? I say while argument vector ++. You see, I have a prefix increment of my argument vector. So I take the pointer in position 1. I skip the one in position 0, which is the path toward the program itself. And then I dereference it, okay? I'm gonna dereference the pointer starting from the one in position 1. And then I put the string, you see? I just give as an input what? I give the pointer because I dereference argv. Argv that every time is going to increase. What do I get here? Well, with this dereference, I get the pointer. I don't get the char. Pay attention here. I dereference argv, which is a pointer to an array of pointers. So dereferencing this is going to give me back the pointer. I think you have the tools by now to understand this code. And maybe stop the video, try to understand very well what is going on. And keep in mind this image. With this image, it's super easy. All right, this is the pro solution. Basically, in 2 lines, I'm going to resolve this riddle. We keep going on. We have to print the parameters in reverse. So to print the parameters in reverse, we can exploit the argument counter variable that up to now we haven't used. As you can see, I have the put string function as before, which you know by now. And then I have my main function. Look carefully now. This time I use the argument counter. I say while argument counter with the prefix decrement, you see? For example, here I have 4 inputs, which are the name of the program, the first, the second, and the third input in my command line. So I have argument counter is equal to 4. I want to start writing from the last one. So the one in position 3, you see? Okay, so I decrease my argument counter. With this prefix here, I'm gonna for sure decrease argument counter before using that. So I start from 3. I'm gonna print argument vector plus argument counter 3, which is this one. You see here I use the pointer notation, but maybe it's better if I write with the square bracket, which is gonna be more easy, I guess, for you. So I just write like that. You see, I have argument vector in position argument counter, which is 3. Basically, you have this point here. You're gonna write the argument in position 3. Then I decrease argument counter, right? So I go here, I write this one, then I write this one, and then will I write this one? No, my friend, because this one is in position 0. When I reach while argument counter is 0, this is a false. This is a false, so it's gonna decay. I'm gonna write in reverse order, skipping the one in position 0. That's super easy. 2 lines, my friend. Okay, let's see if it works. I'm gonna compile and then just launch hello world dem. And as you can see, it works pretty well. It's gonna give me back all the inputs in reverse order. Amazing. So you see, 2 lines. You just have to use this time the argument counter. We're gonna exploit it. All right, we are done with this one. Now we have to make these sort parameters. This is gonna be the most difficult one. But basically we have all the tools we have learned in previous exercises, all the things we have to know to make this program work. First of all, I want to launch the program and see how it works. For example, I compile and I launch with hello, how are you? You see, I'm gonna get all the strings in lexicographical order, like in the dictionary. If you don't understand what is lexicographical order, there is a very easy response on Stack Overflow, which is this one. These values are in lexicographical order. You have 1, then you have 1, 0, and then you have 2. Why? Why you have 2 after 1, 0? Because 10 comes after 2 numerical order, but 10 comes before 2 in alphabetical order, because 1 is before 2. We're going to compare 1 with 2. You see, you can see these 2 elements like letters. For example, this is an A and this is a B. And we do always the comparison between positional elements. So this is the first letter of my string, and this is the other first letter of the second string. We're going to do the comparison between this and this. It turns out that this is inferior, quote unquote, than this one. Okay. All right, let's launch again this program. We do, I don't know, all the letters, so it's going to be super easy to see. So you have B, C, F, and X, Z. You get order, basically. You get lexicographical order. Okay, let's understand how this program works. For this program, I have different functions. As usual, I have my divide and conquer approach. We are going to understand, starting from the main. We are going to do the process like the computer does. So I have my main function, and the first thing I'm going to do, I'm going to call the function ft_sort. ft_sort, I have argument vector +1 and argument counter -1. Why is that? Well, because you see the image here, I want to skip the argument in position 0, which is the name, the path of the program. So I'm gonna give to the function just these 3. The function, the receiver function ft_sort is gonna receive a pointer to an array of pointers that is gonna start from this. So it's gonna have 0, 1, and 2 for hello world dem. And then of course I'm gonna give back argument counter -1 because we have an argument less. So let's go to the sort function so we can understand better what happens. Here it comes. Here we have the sort function, which is kind of longish, thanks to all the comments that I always make, but this is not super long. And this is a bubble sort algorithm. I already made a video about, so I won't explain you again how it works. I just gonna link to you the video. You can understand by yourself. Basically, this function is gonna get this argument vector, namely a pointer to an array of pointers that is going to be with only the arguments that I want. and then it's gonna receive argument, I use s here, but is argument counter, argument s, namely arguments equal 3. Okay, this is the view of my ft sort function. Then I have my algorithm. I have my algorithm that is gonna do the swaps. As I told you before, I have an entire video about, so you can really understand better. So watch the video, screen this image, understand by yourself. It is not super easy, but not difficult. The interesting part here is that I'm gonna make a swap thanks to these 2 lines. I'm gonna make the swap thanks to this ft string compare. So I have one function that is gonna compare one string and the other one. Namely, it's gonna compare argument vector in position j, argument vector in position k. J is 0 and k is 1. So we have 2 different pointers, 2 different strings. This function is gonna take these 2 strings and is gonna say, hey, this one is bigger than this one, or this one is equal to this one, or you got the point, right? The string compare function. I have also a video for this function. So I say, if this function is gonna give me back a value major than 0, what do I have to do? Well, I have to make a swap. So you see how I treat strings essentially like numbers. Thanks to this function, I can make the comparison of these non-scalar objects, right? Objects that have different parts. But I don't care. I can perceive a string as a number that this function is gonna give me back. And the swap is gonna be done to the pointers. I'm gonna swap the pointers in position j with the pointers in position k. You see? So understand how the bubble sort algorithm works. Once you understand the idea behind the bubble algorithm, for this specific point, you have to understand the string compare. I prompt you again to watch the video, and then you have the swap. Again, I have a video also for the swap. So you can understand the bubble algorithm. You can understand string compare and the swap. It's gonna be super easy. When you have all the pieces of this puzzle, you just link them together and you have your beautiful algorithm. For example, this is the algorithm for the string compare. Very briefly, I'm gonna explain to you. It's gonna be while the chars are equal, you're gonna keep increasing the chars. When you stumble upon some chars that are not equal, the loop is gonna end and you're gonna return at s minus at s1. This end at s1 is just for when the strings are equal, so we can end the while loop. Again, just watch the video if you want further details. The swap function you know very well. The trick here is that here I have a pointer to a pointer as an input, but there is nothing fancy to understand. You have just a temporary variable, which is a pointer to a char. Inside this temporary, you just put a pointer, the reference p. What is going to happen when you do reference p? Well, you get a pointer, because you know, right? When you do reference p, what do you get? Well, you get a pointer to char. You can read this in this fashion. But by now, I think you don't need any further explanation for this kind of things. If you are at this level, you must be really good. So you have a swap of pointers, you have a string compare, and then you have the put string function that you just saw before. This is a function that is able to print all the chars inside a string. So I have all the pieces. I have a put string, I have a swap function, which is gonna swap the pointers. Then I have a string compare. Then I have my algorithm, you see, that is gonna perform a swap when a string is major than the other. That's it. This is the algorithm to print the argument in order. Then very easily I say while plus argv, because I want to start here, right? I want to start here. Inside these slots, now I have all the ordered elements, because all the f sort has done is magic. So I'm gonna start one position more. While I have a pointer, namely starting from here, you just print that. You just print that, you're gonna print that string. That's the algorithm, my friend. I don't know, is it complicated? You just have many pieces to glue together to perform this magic. Of course, I have a video basically for every function. I have a video for the swap, I have a video for the string compare, I have a video for the bubble sort, I have a video for everything. You can dig as down as you need. The cool part is that once you create these little pieces, little functions, you can consider the put string operation or the swap operation like an atomical part. I don't care anymore how it is implemented. For me, I have ft swap p and p1, which is an operation that is gonna swap the elements. I don't care about how it is implemented, really. So basically, the function becomes a new operator. And I, as a programmer, I have only this. I have my main, you see? What do I have to do to print the sorted element. You might say, well, I have to sort the elements. Okay, I'm gonna sort everything and then I'm just gonna print. You see, this ft sort is gonna hide me all the complexity that is happening. That's what happens when we use the printf function, right? We use this magic function, you just plug in all the inputs and magically something is gonna happen in the terminal. That's the same idea. So how to solve this problem? Well, you just sort the arguments and then you print them. That's the solution for this problem, all right? Okay, that's basically it. I will push all this stuff on GitHub so you can check for yourself better. I don't go too much deep to don't make the videos too long because I think by now you're pretty good if you reached this level, okay? All right, that's it, my friend. Enjoy. Thank you for watching.